Hello everyone, welcome back to the series. In this video, we're going to generate the files necessary to make each of the 3 custom components that we've built so far. For the sidewall, that's going to be a PDF vector drawing that the laser cutter can then use to cut out the part. For the motor mount, it'll be an STL file that can then be sent to a slicer to generate the G-code necessary to build the part. And for the chassis base, we're just going to create a one-to-one template that can be glued to the top surface of the MDF or plywood that this part is being built from, and can be used as a template to cut out the part. So we're going to start with the chassis base, and we're going to create that one-to-one template. To do that, change the workspace from design to drawing, from design, and because we're going to print this template out, we need to change from ISO to ASME and change our sheet size to A, or an 8.5 by 11 sheet of paper. We can keep the units as millimeters for now. Press OK, and a drawing will be generated. So the first thing it'll ask you to do is to insert your drawing view, but we're going to wait on that for a second because we need to edit this drawing first. So press cancel. Hit the triangle under Sheet Settings, and right-click on Title Block, change Title Block. And because we're going to print this template out, we don't want it to actually look like an engineering drawing, so we're just going to uncheck Display Border and Display Title Block. Press OK, and now we just have a plain 8.5 by 11 sheet of paper that we can work with. So now we're going to insert our drawing view. So we're going to start with Base View, and we're going to change the orientation from front to top. And we need to change our scale to 1:1. This is really important because otherwise the dimensions will not be correct. Okay, so just click anywhere on the sheet of paper and then press OK. And a 2D view of the part will show up. So the only other thing that we need to do for this drawing is we want to mark the center points of each of these circles, or each for the bolt holes, which will make it a little bit easier when we're using this template to make this part. We can use a center punch on each of these holes to mark out where they need to be. So just on every single bolt hole, so go to center mark and then click on each of these bolt holes. Okay, so that's the one-to-one template complete. So we're going to save that. Actually, we're going to go into our car project. We're going to create a new folder called Drawings. And then we can save this component, or save this drawing as chassis base, and call it template because it's not really an engineering drawing, it's just a template that's being used. Okay, and we're going to save. Oh, and we want to actually move that into our drawings folder. There we go. Okay, and then we're going to create a PDF of this drawing. So right here, output PDF. So all sheets is good. Press OK. We're going to call this chassis base template. And we're just going to save it to our desktop for right now. And you can see now we've got a PDF of our one-to-one template with all our center marks laid out. And we can just print this on any printer and cut it out with scissors and glue it to the top of our MDF or plywood and cut out the part with a scroll saw and drill out the holes with a drill press or a hand drill. Okay. So the next part that we're going to make the template for is the sidewall. So when you're laser cutting a part, you need another 2D vector image, essentially, which basically what a vector image is it means that instead of using pixels to define the lines, it's done using vectors and basically a bunch of mathematical formulations. And what that means is that you can infinitely zoom in on these drawings. So there's a bunch of different formats for vector drawings. Most common that you'll see is a DXF, but the laser cutters that are used in the labs, the Dremel laser cutters, actually accept PDF, which is an easy format to create, as we just created with the chassis base. So we're going to do pretty much the exact same thing. So go Drawing from Design. The sheet size doesn't really matter in this case, but just for consistency's sake, we're going to do another A sheet of paper. Okay, and once again, we want to make sure we delete any of the extra lines, because basically any line that's on this PDF will try to be cut out by the laser cutter. So we need to make sure we do not add any additional cut lines. Okay, so we're going to get rid of the border and title block. Insert a base view on the top. And once again, it's important that we need it as a one-to-one template to get the dimensions correct. So place it and press OK. All right, and then let's save this in the Drawings folder under Sidewall Template. And again, we're going to create a PDF. So there we go, save that as PDF. And that's it. So if you're going to cut this out in the labs, you go to the Dremel software, upload this PDF, follow the instructions, and then you'll be able to cut the part out. Okay, so the last file that we need to generate is an STL for the motor mount. So Fusion 360 actually has some nice built-in tools for 3D printers. So to generate the STL, go to File, 3D Print, and you might see this option, Send to 3D Print Utility, already checked. So you can actually send this STL directly to the print utility that you want, whatever printer you're using. But right now we're just going to create the STL. There are other instructions available on Canvas that show you how to use the printers and basically going from the STL file to the actual printer. So I'm just going to focus on generating the STL. So what we need to select is the body that we want to mesh. So it's this motor mount here. And then we can change the refinement. You see if I go to higher, it'll basically make more triangles. But medium should be fine for now. And you can preview the mesh here with that button. And then press OK. And it'll prompt to save. So we're just going to name this motormount.stl. And there we go. That's our 3 files necessary to make the parts.